For our first video of the fourth quarter, we're going to talk about neutralization. Now, this is a reaction that occurs between an acid and a base. But first, before we really get into it, we're going to have to talk about the difference between a strong acid or base and a weak acid or base. Really, the difference we're talking about here is that, as we said, an acid is something that gives up a proton. It donates a proton when it's added to water. But it turns out that not every acid will completely dissociate. Not every acid, for every mole of the acid, will you get 1 mole of hydrogen ions. Some acids you do. There are strong acids that will 100% dissociate, completely break up. For example, hydrochloric acid here. It will completely break apart into protons, or hydrogen ions, and chloride ions, essentially to 100%. However, there are some acids, in fact, most acids are not strong acids. They're only going to break up a little bit. For example, you may recall acetic acid from class will indeed produce hydrogen ions and the acetate ion, but only a very, very small amount of it. You'll still have mostly this. You'll only get a small number of hydrogen ions. This is going to cause a difference, as we will see, especially when we start talking about pH. This is not to say that weak acids are not dangerous. There's a lot more that's going on to whether something is dangerous or not than just how much hydrogen it produces in a solution. And do keep in mind as well that if we had a much more concentrated solution of this weak acid, it could be more acidic than a low concentration of the strong acid. Again, more calculations on that coming up later. So again, here's a little picture of what's happening. With hydrochloric acid, it completely breaks apart to make the hydrogen ions, shown here as combining with the water to make the hydronium. So you see we have all the chlorides separate. And here we have acetic acid. They're mostly all together still, but in a small amount it does break up into the acetate ion and the hydrogen ions. So, how can you tell the difference between a strong acid and a weak acid, or a strong base and a weak base? Well, really the only way is memorization, but luckily for us, most acids are not strong. So if you just remember a quick little list here, shouldn't be a problem. So, the list are just these 7 right here. For practice, you may want to go through and double check that you can name all of these. If it is not one of these acids here, it is a weak acid. And as far as strong base, weak base, strong bases have hydroxides. If it's a base and it does not have hydroxide as part of its formula, it's not strong, it's weak. So, again, I know I hate to have you memorize things, but I am going to expect you to know this list. It's not too tricky. You'll see that you've got 3 of the binary acids and then a couple of the oxyacids. Okay, so the key of neutralization then is what happens when we mix together acids and bases. And we're going to start looking at this by a reaction between a strong acid and a strong base. Weak acids and weak bases, you'll have the same reaction happening, just at a much lower amount in some cases. So, hydrochloric acid and sodium hydroxide. Well, first what's going to happen is these are going to dissociate, then we'll get a reaction. So, let's take a look at that. Okay, so let's consider then. We've got hydrochloric acid and sodium hydroxide. So if we just first consider the dissociation of hydrochloric acid, it's a strong acid, which means it will break up completely. It's going to break up into hydrogen ions and chloride ions. And the sodium hydroxide is going to break up into sodium ions, and what else? Hydroxide ions. Remember, hydroxide's a polyatomic ion, so that sticks together. So then the reaction is going to occur between these two sets of things here, these four things. So if we go ahead and write that all out, we'll see H plus Cl minus plus sodium plus hydroxide. Now, here's what happens in a neutralization reaction. You'll recall from in class the reaction between an acid and a base results in the production of water and what else? A salt. In this case, it happens to be what we would typically think of as salt, sodium chloride. So this is what's happening. Neutralization reactions are neutralizing the acid and the base. Well, now, of course, this reaction would work if we had equal molar amounts of these added. If we didn't, if we had more of one or more of the other, we would still have some hydrogens left over at the end. You can see this would work if we had exact equal amounts of everything, stoichiometrically exact. And that's all that a neutralization reaction does. That's as far as we really need to be concerned about it ourselves for our purposes in this class. We can also break it up a little bit and talk about ionic equations and net ionic equations. If you would take some time and look at that up in the book, I'd rather show that to you in class next time than trying to show you by drawing pictures on Microsoft Paint. Okay, one more thing I want to get to. I mentioned it briefly in class, the idea of a conjugate acid and a conjugate base. So, in a neutralization reaction, in a reaction between an acid and a base, the acid is going to become, it's going to have a conjugate base after the reaction. The base is going to have a conjugate acid. So we'll note here that the hydrochloric acid, after the hydrogen leaves, it's now a base. Because remember, a base can accept a proton. Acids give up a proton. And the base here, water, became hydronium. An acid, it can give up a proton. So here the acid has a conjugate base. Here the base has a conjugate acid. What these arrows here mean is that we can reverse the reaction. These can be the reactants and these can be the products. However, typically speaking, the stronger the acid is, the weaker its conjugate base is. So what could you guess about the strength of the chloride ion as a base? Well, what do we know about the strength of hydrochloric acid? If you're thinking it's one of those 7 on the list of strong acids, you are correct, which means that since it is a very strong acid, then the chloride ion is a very weak base. Water is, it's stronger than some things, weaker than other things, but this chloride ion here is never going to be able to take a proton from the water here, from this hydronium. It's not going to get it back. That's why it breaks up 100%. We're going to go ahead and stop there for today. We'll work with this some more in class next time and also do an introduction to the mathematics behind logarithms. If you've got any questions, please come see me. Also remember, follow along in your book in the chapter on acids and bases.